Good morning, Mr. Abhijit. Welcome to our AR stand, and we welcome you heartily for this COP28 event, our kickoff event for Johnson Controls. In this AR stand, we wanted to present our flagship air-cooled variable speed drive chillers. We have a nomenclature called YVAA, which stands for York Variable Speed Drive Air-Cooled Generation, and A is the generation of the chillers. In these chillers, what we have been doing with York in our air-cooled machines is that when Johnson Controls does any product introduction to the market, they always lead the innovation and technologies into the market. Air-cooled chillers, variable speed drives is one of its first kind introduced by York and back in 2005, where now the industry and technology is now talking towards the sustainability products and greener products, but we had this idea of bringing such innovations back 20 years before. So this is one of our product which we have done that. This is an extended version of our water-cooled machines where we introduced water-cooled chillers variable speed drive in 1979. So we are almost 44 years old in a variable speed drive technology. We have all the expertise. When the flagship of Johnson Controls added to the York's product line, it helps us to give a lot of other additional added features to this. Like any other typical air-cooled machines, of course it has the condensers, it has the compressors, it has an evaporator, it has a control panel. But what we added is everything is an latest technology into that. If you start with right from the condenser by itself, in these machines, the typical condensers which used to come in an air-cooled chiller used to be in copper aluminum condensers. The copper aluminum condensers having two different metals, it always tend to an corrosion, galvanic corrosion happens when you put them into an environment, and oxidation happens between two different metals, they started corroding to each other. That's why we introduced this in this chillers, a V design on the condenser coils, where you can see here. These are made with a single material which is called Microchannel condenser coils. We introduced them into the air-cooled chillers back in 2010. This is then again an innovation even in the components levels of the chillers. And coming to the compressors by itself, in the compressors we introduced the variable speed drive technology, okay, and where this was never before introduced in an air-cooled machine. What does a variable speed drive does to a chillers? Basically, when we design an air-cooled chillers for a design ambient, for example, for an instant, Dubai has a design ambient of 46 during a peak summer condition as per the municipality's regulation. Why does we have to select a design ambient for a machine is that during a peak summer time as well, we don't want anyone to have an effect of the cooling. But however, we all know that 46 ambient doesn't happen throughout the year. Today, when we are standing on a 1st of December, the average temperature, it reaches peak up in the afternoon, say about 30 degrees. But the design is always done at 46. Even ASHRAE and AHRI, they just say that these temperatures of design conditions happen only 1% of a year. A very simple example how we correlate this is that a variable speed drive chillers will always reduces its speed and takes only power required to operate the chiller to meet its performance condition. Like for an example, which I always claim in several of our discussions with customers is that when you wanted to accelerate a chiller, your car at 100 kilometer speed, so you used to press your accelerator for 100. When you want to reduce it down to 60 kilometer speed, you do not apply a brake to bring it down to 60. You basically lift your pedal, regulate your speed to come it down to 60 degrees. The petrol consumption or the fuel consumption during 100 kilometers is definitely higher than it is a 60. That's exactly what applies over here. When the ambient is not that high, we reduce the speed of the compressors to make sure that it consumes only so much of power needed to do that, which in turn could able to get you approximately about 20% of energy saving on your electricity bill conventionally with your typical air-cooled chillers what we have. This is about the condenser coil itself. These fans throw out the condenser, the ambient air through the condenser coil to heat rejected to the atmosphere. The inventions what we have in this condenser fans by itself is that we do have different application to handle different situation. If somebody wants really a quiet machine, we have an ultrasound fans to do very quiet noise. If you want a situation where it is in an industrial area, you want more air to be there, there is no sufficient layout plans available in your site, we could able to have an high static fan or an high airflow fan to able to cater that requirement. This chiller is completely tailor-made to an extent where each and every project can suit your requirement precisely. We are no longer doing an model-wise chillers that say, for example, if your building requires a 232 ton, we don't offer anymore as a traditional way of giving a 250 ton, whether you like it or don't like it, this is the models we have. We no longer do that. Every single project is unique. Your project is unique for you. So we select the machines to do the requirement precisely to 230 ton, so that it will not consume more power than it is required for. The condenser fans, the latest technology what we are adopting is that we are also putting an electronically commuted fans, which is the EC fans, which can alter its speeds along with the compressors when there is no requirement to do that. That is the next advancement what we have done in this machine. These machines also come with an evaporator, which is, if you see the cross section of these chillers, you will see the evaporators here, the black shells over there, which actually transfer the heat from the your medium from the load, which is a chilled water coming from the building, to the refrigerant, which there the heat is transferred back to the atmosphere. This innovation what we have done here is that typically the chillers used to have a DX type evaporator. These DX type evaporators used to have an issue that they are less efficient. When the water is in the shell itself, there is a difficult situation when over a time of the years the water forms the scaling inside the shell. There is no way to clean those scaling. Then the only way is to remove the evaporator completely. We introduced an hybrid falling film technology, which was patented by York by the time for the past 10 years actually. So where we introduced the water inside the tubes. So anytime during a scaling, during a life of your chillers, after 10 years, 15 years, there is an ability to clean those tubes by brushes. So that is the next advancement what we have done. And coming about the control panel by itself, so all of these variable speed drives and all the components of the things are entirely built into a NEMA 34 IP54 control panel. So where the variable speed drives, the IGBTs, all of those features are kept inside, protected well inside the things, suitable for a machine which can operate up to 55 degrees C. And to protect, we also wanted to ensure that the cooling of the variable speed drive is not done with an typical air-cooled system or a refrigerant-cooled system. We kept a separate system of a glycol cooling system for that, so that the refrigerant circuit does not affect with the variable speed drive cooling as well. That's it about our products.